Our topic is inverse functions, and inverse functions are sets of ordered pairs obtained by exchanging the coordinates of each ordered pair.
Sorry.
Okay, inverse functions can be solved in multiple ways. These functions can be solved by equation or by a table of values. Inverse functions can also be solved graphically or algebraic relations. The inverse of a function f of x can be illustrated in the picture to the left. So the x and y are interchangeable. There's the table that you can make, and the function and the inverse function of a line are displayed in the graph below. Whether you're looking line G or at line F, the domain and the range switch, or the x value becomes the y value, and the y value becomes the x value. Another example of this is displayed in the graph or the t table to the right. The most common inverse function is written as f of x, but many functions have inverses of them, like quadratics and logarithms. Some more functions and their inverses are shown in the table below.
All right. Yes?
Okay. Next step would be graphing. There are a few ways to solve an inverse function. One way is graphing. Graphing isn't always the shortest method, but it's one of the most efficient. And then these down here are actually going to help two different ways, either solving linear or quadratic. Okay, step one. The first step in graphing linear inverse functions is to write out the problem. Most people are more used to y equals and f of x equals, but in this case, since they're interchangeable, use y equals. Step two is, the second step is to solving a linear inverse equation is to swap the x and y values. So instead of y equals 2x minus 5, it becomes x equals 2y minus 5. The third step is to add or subtract depending on what extra numbers you have. In this case, it would be adding 5 to each side since it's 2y minus 5. Okay. The fourth step would be to divide each side by 2 to get your y by itself, and your function now becomes y equals x plus 5 over 2. Step 5 is now you have both equations that you need. Now it's time to make your t table. So we just imported just for your x values 1 through 5 shown here for each equation. And then we just plotted each of our points on our graphs, and then we draw lines and see if they reflect or intersect at any point. And then step 8 is just seeing that, okay, they intersect at one point and they reflect over the line y equals x, so they are inverses. Yeah, I think it has to go up to about 10.
Okay, this one is a quadratic inverse function, and it's basically the same thing. You change f of x to y, and then the second step is x equals y squared plus 1. The third step is to subtract 1 from both sides of the equation. And then the fourth step is to square root both sides. And you get y equals plus or minus the square root of x over x minus 1. And you make your t table to figure out what your points are. And then you plot your points and connect them. And there's your graph.
And then the 8th step is just examining to see if they reflect, and they do reflect over each other.
You can determine whether or not two functions are inverses of each other by finding both of their compositions. If both compositions equal the identity function, then the functions are inverse functions.
And to prove that, you would use f of g x equals x, or g of f x And then the two functions, f and g, are inverse functions if and only if their compositions are the identity function.
Okay. All right, ladies and gentlemen.